Hello class. Today we're going to be working on solving exponential equations. What I'm going to do is give you a few strategies and then work through some examples that use those strategies, and then you'll get a chance to practice those in the coming days. So the first strategy that we're going to do is when we are given an equation, we're going to express each side of the equation so that they have the same base. Because when we have the same base, such as base of b raised to an exponent is equal to that same base raised to a different exponent, then we can say that those exponents are equal to each other. So, as I look at this first example here, 5 raised to the 3x minus 6 equals 125, I want to think to myself, can I write 125 with a base of 5? Well, I can, because 125 is 5 cubed. So 5 raised to 3x minus 6 is equal to 5 cubed. So we're going to now that we have the same base, we can set the exponents equal to each other. 3x minus 6 is equal to 3. Add 3 to each side, we get 3x is equal to 9. And we'll divide by 3, and x is equal to 3. So we were able to solve for x. On this next one, we've got 8 raised to the x plus 2 and 4 raised to the x minus 3. My first natural inclination is to say, hey, can I write 4 or 8 as a base of 4? Well, I can't. However, I can write 8 and 4 as a base of 2, because 8 is 2 cubed, and 4 is 2 squared. Now that 2 cubed is being raised to the x plus 2, and that 2 squared is being raised to that x minus 3. So when we have a base raised to a power raised to another power, we're going to multiply the powers. So we're going to have 2 raised to 3 times x, which is 3x, plus 3 times 2, which is 6. And that's going to equal the base 2, and the 2 is going to be multiplied to x, so we get 2x. And the 2 is multiplied to negative 3, so negative 6. So now we have the common base of 2, and we can take our exponents and set them equal to each other. I'm going to come over on the next column. 3x plus 6 equals 2x minus 6. Let's subtract 2x. We get x plus 6 is equal to negative 6. I'll subtract 6 from each side. X is equal to negative 12. The second strategy that we can use is to use logarithms to solve them. Sometimes when we are given an exponential equation, the variable is the exponent, and it's just really difficult to know what that might be, so we can write it as a logarithm. So on 5 raised to the x equals 134, we could rewrite that as log base 5 of 134 is equal to x. Now we can use our calculator to do this. If you have a TI-84, you're going to use that math button and then choose A, and then it will give you log, and it gives you a little box here, oops, and a box here. And you can just fill those in. If you're using a scientific calculator or a TI-83, you can use change of base, which then you'll have log of 134, and you'll divide that by log of 5. And either way, let's round it to 2 decimal places. We're going to find that that's 3.04. On this one, we have 10 raised to the x equals 8,000. So let's rewrite that as log base 10. Well, if it's base 10, I don't have to write it down, of 8,000 is equal to x, because that's our common log. I don't have to do a change of base for this one. I just type that into my calculator and round it to 2 decimal places. In this case, it's 3.90. The third strategy is very similar to the one that we did before, but we have to do one more step because we have an exponential equation that's not all by itself. So we want to make it all by itself by isolating that. Then we're going to do what we were doing in the last strategy, using logarithms to solve. So on this first example, 7e raised to the 2x minus 5 equals 58. This e to the 2x is what I want to get all by itself. So I'm going to add 5 to both sides of the equation. I have 7e raised to the 2x is equal to 63. Now I'm going to divide by 7. I have e raised to the 2x is equal to 9. Oops. Now I can write this as log base e, which is the natural log of 9, is equal to 2x. I just want x, so I'm going to divide by 2. And in my calculator, I'll put in natural log of 9 divided by 2, and I find that x is equal to 1.10. The fourth strategy occurs when we have exponential expressions on each side of the equation. So we're going to take the logarithm of both sides of that. And we can use common or natural. This time I'm going to use the common. So I'm going to start off, and I'm going to use up quite a bit of space here. So I'm going to write this. Oh, you know what? Yeah. There we go. Oops. Let me erase that. We're going to start out by taking the log of each side. So I'm going to take log of 3 raised to the 2x minus 1. And that's going to equal log of 7 raised to the x plus 1. So now this exponent that I have here is going to come out as the coefficient 2x minus 1 times the log of 3. And we'll do that same thing here. That x plus 1 comes out as the coefficient times the log of 7. Now I'm going to distribute this. So I have 2x log 3 minus 1 log 3 is equal to, and we'll do the same thing on this side, x log 7 plus 1 log 7. Now what we're trying to do is find the variable. So any term that has an x in it, let's put them on the left. So this term is going to stay here on the left, and this term I want to move to the left. So I'll subtract x log 7. So I'll have 2x log 3 minus x, oops, I have to do that to each side, right? X log 7. And then anything that doesn't have an x in it, I want to move to the right. So this term, I'm going to add log 3 to each side. So I'm going to have equals log 3 plus, then this side stayed there, log 7. That doesn't look like we've gotten anywhere, but because each of these terms has an x in here, I can factor that x out. So it's going to be x times 2 log 3 minus log 7. And that's going to equal log 3 plus log 7. All right, to get this all by itself now then, we're going to divide by 2 log 3 minus log 7 on both sides of the equation. So that cancels out. Now this huge mess right here is what x equals. We're going to put that into a calculator. Now if you are not using the fraction where you get a little box over another box so that you can type these in there, then make sure that you are typing the numerator in parentheses and then the division bar, division, and then the denominator in parentheses. Try that, put it in your calculator. You should be getting 12.11. If you didn't get that, you're going to want to check to see what you're doing wrong with either a classmate or me, because we want to make sure that your calculator work is not what's causing any errors. Then we get to this really fun one. Our fifth strategy is to factor. And, you know, I've said it before, factoring never goes away. We've always learned this. Now, this one looks really funny. When we've factored before, we've done, you know, ax squared plus bx plus c equals 0, and we factored that trinomial. This is called quadratic in form. So we're going to factor it in the same form as this. So let's take this middle term right here, e to the x, and we're going to make that be u. So we'll substitute that in there. So we're going to have, so this e to the x is going to be u. So we have u squared minus 8u plus 7 equals 0. That looks like it's much more in this form of ax squared plus bx plus c. So I can factor this. U squared is going to be u times u. And then I want the factors of 7 that add up to negative 8. So I'm going to have negative 7 and negative 1. And now I can, now that I have these factored, I'm going to take this e to the x and put it back in for u. So I have e to the x minus 7 times e to the x minus 1 equals 0. And our zero product theorem states that if you have two products that equal a 0, then one or both of them have to equal 0. So we're going to set that up. E to the x minus 7 equals 0, and e to the x minus 1 equals 0. So we have e to the x equals 7, e to the x equals 1. We'll set this, we'll go back to that strategy where we're going to use the logarithm then. So this is going to be the natural log of 7 is equal to x, or the natural log of 1 is equal to x. I'm going to use a calculator for this one, and I find that x is 1.95. When I can use a calculator for this one, but one of our basic properties is that the natural log of 1 is 0. So these are my answers.